Gate 2017 question was this. Now, so this is Gate 2016 EC question. Let's solve this. Okay, now it is given that we have to find VC, capacitance, for t greater than 0. Now first of all, we draw the circuit for t less than 0. Now since for t less than 0 the switch was at location 1, so this circuit is useless, the circuit which is to the right of this, so it is of no use. For t less than 0 the circuit will be 10 volt, battery, 3 ohm resistance, 2 ohm resistance, and a capacitance of 0.1 farad. Now since the circuit was in location from t equals to minus infinity to t equals to 0 minus, and since this time duration is very long, so I can assume that the capacitance was at steady state. Okay, capacitance was at steady state, and at steady state the capacitance act as an open circuit. So I can say that the capacitance was open circuited and the voltage across this is represented by VC0 minus. And by voltage division rule we can easily say that VC0 minus is 2 upon 2 plus 3 into 10, that is 4 volt. So I can say that the capacitance was initially charged by voltage, that is 4 volts. Okay. Now for t greater than 0. Now since for t greater than 0 the switch is connected at location 2, so the circuit will be capacitance C, resistance 4 ohms, there is again a resistance 2 ohms, 2 ohms, and 5 ampere current. Okay. Now, so this is for t greater than 0, the circuit is like this. Now we know that we have to find VCT. Okay, VCT equation is actually V infinity minus V0 e to power minus t by RC. This is a standard equation where V infinity is voltage across capacitance at t equal to infinity, and R is R equivalent seen by the capacitor in the circuit. Okay, now and V0 is actually the voltage at t equals to 0 plus, and since in the capacitance voltage at t equals to 0 plus and t equals to 0 minus is same, so V0 is equals to 4 volts. Okay, now to find V infinity, so V infinity means the voltage across the capacitance at t equal to infinity. Okay, so how to find this? We know that at t equals to infinity the capacitance will be at steady state, so the capacitance at steady state is open circuited, so it will give me V infinity, the voltage across capacitance. Okay, so capacitance is open circuited. To find out V infinity, okay, now if we know that this current, which is 5 ampere current, will not go in this direction because capacitance is open circuited, so whole current will go through 2 ohms resistance, and the voltage across drop this will be 10 volts, so we can say that V infinity equals to 10 volt. Very simple. Okay, now To find out R equivalent, I will just add a page here. Okay, now we can, to find out R equivalent, that is R resistance seen by capacitor in the circuit. Now what is this? So to find out R equivalent, we know that we remove the capacitance and mark A and B at the terminal of the capacitance, and then find the Thevenin equivalent resistance seen at the terminals AB. So we have to find RAB or R Thevenin. Now we know that to find out the Thevenin resistance, we actually remove all the independent sources. So to remove the independent current source, we open circuit that, and to remove the independent voltage sources, we short circuit it. So to find RAB, we will open circuit this independent current source, and we can see that the circuit is simply like this. So this will be open circuited. Okay, RAB. So this is A, this is B. So we can see that RAB is actually a series combination of 4 and 2, right? 4 and 2. So RAB is 6 ohms. Very simple. So the equation VCT is equals to V infinity, that is 10 volt, V infinity minus V0, that is 4, e to power minus t by RC, where R equivalent is 6, C is 0.1 farad. Okay, so the equation will be 10 minus 6 e to power minus t by 0.6 volts. Okay, so since this was an option question, options were there, so we can easily see that it is 10 minus t, e to power minus t upon 0.6. So the option is D. Okay, so this is a question, right? Now another question. Okay, so this is also GATE 2016 EC question. Okay, electronics and communication question. Now a very good question that actually combines the concept of LC circuits, analog and networks. Okay, now so it is given that at t equals to 0 the switch was opened, right? So if I draw the circuit for t less than 0, first of all I draw the circuit for t less than 0, and we have to find out the steady state magnitude of the voltage capacitance VC. Okay, so it's a 10 volt battery. Okay, so we have to find VC. So C is also given, L value is also given to us. I'm just writing L and C, right? Now for t less than 0, since this battery is pushing the current in this direction, that is, it will push the current in right direction. Okay, but this diode will stop the flow of current because this is N terminal and this is P terminal, and since it is given that diode has zero reverse current, that is no current will flow in the reverse direction, that is from N to P no current will flow. So no current will flow from N to P. Okay, and whole current will flow through the inductance. So for t less than 0, this capacitance is not present in the circuit because this diode is open or this diode is off. So for t less than 0, if I redraw the circuit, by open circuiting the diode, then the circuit will be in this format. So this is open. So capacitance is actually not in the circuit for t less than 0. Now easily I can see that since this circuit was created at t equals to minus infinity, thus at t equals to 0 minus, that is for a very long duration, the circuit was in this format. So I can say that inductance was at steady state at t equals to 0 minus and inductance was fully charged. Now since the fully charged inductance is a short circuit, so we can say that at t equals to 0 minus the current in the loop will be 10 amperes and this inductance is charged in direction top to bottom by 10 amperes current. Okay, right? So at t equals to 0 minus, inductance was charged by 10 amperes current top to bottom. Now for t greater than 0, this switch is turned off, that is, it is opened. Now when it is opened, this 10 volt and 1 ohm resistance will be of no use, and for t greater than 0, I will have to add a page here. For t greater than 0, the circuit will be like this. Okay, LC circuit, because 10 volt and 1 ohm resistance will be removed from the circuit. Now before solving for the solution, that is VC, we will first of all solve for a parallel LC circuit. Suppose we have a parallel LC circuit where L is initially charged from top to bottom by 10 amperes current and C was initially uncharged. Okay, and we have to find VC and we will also draw IT. Okay, right? So before solving this, we will solve this. That will make you this will help you in actually solving LC parallel also, LC parallel circuits also. So since inductance was initially charged from top to bottom 10 amperes current, so taking the Laplace transform of this circuit, we get that so this is your inductor L, this is your capacitance C, this is your IS, and this is your VCS. Okay, now if we want to find, let us assume that this is grounded, so this node will be at voltage VCS because this is minus, this is plus VCS, so this node will be at VCS. Okay, now KCL at this node A, for example. So we know that incoming current is 10 by S and the outgoing current will be VCS upon SL. So this will be SL and this will be 1 upon SC, right? VCS upon SL is the current going here, and similarly VCS upon 1 upon CS is a current going in this branch. So incoming current equals to outgoing current, as we can see here. So VCS 1 upon SL plus SC is equals to 10 by S. VCS equals to 10 SL upon S 1 plus S square LC. Okay, so this is your VCS. Now we can easily see that VCS is equals to 10L upon 1 plus S square LC, or it is 10 upon C S square plus 1 upon LC. Okay, this is your VCS equation. Also you can easily find ICS, that is actually equal to or I can say IS. So IS is actually equals to VCS divided by the impedance of the capacitance 1 upon SC. So that is actually equal to 10 LCS divided by 1 plus S square LC. That is equals to 10 S upon S square plus 1 upon LC. Okay, right? Now this is equation number 1, this is equation number 2. Now equation number 2, if you can recall, then you know that sin omega naught t ut Laplace transform and cos omega naught t ut Laplace transform, you can easily recall, and you can say that sin omega naught t ut has Laplace transform omega naught divided by s square plus omega naught square, and cos omega naught t has Laplace transform s upon s square plus omega naught square. So by comparing, we can say that equation number 2 and equation number 3 and 4. Okay, so from equation number 2 and 4, I can say that ICT is equal to, by comparing this with equation number 4, I can say that the current is, just multiply omega naught top and bottom. So by comparing this with this equation, I can say that it is 10 cos, here omega naught will be 1 upon root LC into T. Okay, similarly by comparing equation number 1 and 3, we can say that VCS will be equals to 10 divided by C. We will have to multiply by, okay, so VCS can be written as 110 upon C multiplied by omega naught 1 upon root LC, and we will divide it also by root LC, 1 upon root LC S square plus 1 upon LC. So this whole term will give us VCT is equal to VCT will be equal to 10 upon C multiplied by root LC sine of 1 upon root LC into T. So this is your voltage and current. Okay, now if you want to draw it, so I have to add a page here. Okay, now if you want to draw these terms VCT and ICT, then you can see that current ICT is a cosine wave, so it's like this. Okay, so maximum value is 10 ICT, and if you draw VCT, then it will be a sine term. It will be maximum here and it will be 0 here. Okay, it will be like this and so on. So it will be a sine term. Now the maximum value this is 10 under root L by C, the maximum value of VCT. Now this is the current and voltage in the simple LC circuit, but the circuit which is given to us has, I'll just copy the figure, has a diode in it. Okay, so what will the diode make changes in the result? Okay, so very important thing is, as we know in the, suppose the condition is same. Okay, this inductance also charged initially at 10 amperes, this inductance is also charged with 10 amperes, this capacitance is initially in charge, this is also the same case, but here is a diode, but here there is no diode. So I can say that the current will initially, the current was IT here and voltage was VCT. Here also the current is IT So the current equation will be same initially in both the cases, and since the current is flowing in this loop in this direction, so this diode will not restrict the current flow. Okay, and the equation will remain the same. That is, what was the equation? The equation was 10 cos 1 upon root LC t. But when the current reduces from 10 to 0 and after 0 it try to go to negative, then this diode will opens itself. Okay, will open circuit itself. That is, the current will flow only for this time duration. Okay, and after that the diode will turn off, right? And the diode will turn off, and at this time instant we can see that the voltage across capacitance was VCT, that is 10 under root L by C. And after this the current will not flow. So if I draw the voltage and current in this circuit, for this circuit, the current will flow from 10 to 0 and then it will remain 0 forever, because diode will not allow the current to flow in the negative direction.